what type of access will users need in our environment? Well, it depends on that user. For example, if it's a user who requires administrative access to our routers or our switches in our environment, well, then they'll need to be authenticated and authorized to do so. They might be accessing the devices via the console port, the VTY lines, or even the auxiliary port. Regardless of the way they're accessing the device for administrative purposes, we need to be able to authenticate them, number one, and authorize them to do so. However, what about remote users? For example, users who are trying to access local resources in the network, or users who are trying to gain VPN access. Or what about those users inside our local network, and we're using 802.1x authentication in order to control who's allowed to access the network. So you have to authenticate even before you can access the network. Well, in those cases, we have the ability to authenticate and authorize those users as well. So there's various ways that we can control the way that end users access the network or access the devices for administrative purposes. However, what we have to realize is that there is the methods of authentication, for example, utilizing the lines, the console lines, or the VTY lines. And we can set up simple passwords there. We can use our local username and password database on our router to perform authentication. But is that the most scalable solution that we have? And the answer is no. If we want to provide the most scalable solution and the most secure solution for authentication and authorization and accounting purposes, we want to look to external devices that have the ability to hold databases. Those databases of usernames and passwords and what those users can do when they're successfully authenticated. And we see some of those examples here: Cisco Secure ACS, Cisco Identity Services Engine. All of those can be utilized for various purposes of authenticating, authorizing, and accounting our end users. But we're going to use specific protocols when we're looking to external services, external servers for this authentication process. Protocols such as TACACS Plus and Radius come into play. So we'll have a TACACS Plus server set up or a Radius server set up. And the goal of these servers is to provide that authentication, that authorization, and the accounting that we're looking for. And now, why do we want to rely on these external servers? Well, if we don't have external servers, then we're going to have to set up usernames and passwords on every single device within our organization. So every router, let's say we have 50 routers, that means we're going to have to set up usernames and passwords on all 50 of those routers. And we don't want to do that. We'd prefer to have our routers contact those external servers, the Radius servers, the TACACS Plus servers, to ask them if the credentials that were provided by that end user are correct. Or the user's trying to access this particular resource, are they allowed? Well, instead of having that authorization information on the routers, we can have that stored on our Radius and TACACS Plus servers. So here's just a comparison between TACACS Plus and Radius. You can see that for TACACS Plus, we're looking at a Cisco supported standard, whereas Radius is open, defined by RFCs. Functionality for TACACS Plus, everything is completely separated out. So authentication, authorization, and accounting, completely different functions. Whereas Radius, the authentication and the authorization has been combined, and accounting is the only thing that's separated from those two. If you're looking for a reliable communication between the router and the server, then TACACS Plus is going to be classified as reliable because it's using TCP, whereas Radius is using an unreliable transport protocol known as UDP. We have TACACS Plus, that's going to be utilizing CHAP in a bidirectional process, so we're authenticating both the router and the server bidirectionally, whereas Radius, we're only authenticating between the router and the server in one direction. So what we want to realize here is we're not talking about the authentication here of that client. So for example, the client's trying to remotely administer the router. We're not talking about the bidirectional and unidirectional nature here between the end user and the server. We're talking about the router contacting that server and asking it, hey, are these credentials correct? Well, we have to make sure that we are authenticating correctly with the Radius server and the TACACS Plus server ourselves as the router to make sure that we are communicating with that correct device. We're communicating with an authentic device, an authentic database, a TACACS Plus server or Radius server in this particular case. When it comes to confidentiality between the router and the Radius server, between the router and the TACACS Plus server, the entire packet is encrypted, giving us a high level of confidentiality. Whereas with Radius, just the password is encrypted between the router and the TACACS Plus server. If you're looking for a solution that's going to perform extensive accounting, you're going to want to go with Radius because TACACS Plus is very limited and lightweight in its accounting features. So these are servers that you really want to consider for your organization. Typically what we'll see in a Cisco environment is that a TACACS Plus server is going to be used for authenticating management access. So if you are setting up your environment and you want to control using some type of external database, who is allowed to access what device for management purposes, we're going to utilize a TACACS Plus server. But for everything else in regards to controlling who's allowed to connect to the wireless network, who's allowed to connect to the internal network, we're going to be utilizing, using 802.1x, we're going to be utilizing Radius servers to accomplish that.